In our first objective in thermochemistry, we are being asked to use the relationship between mass, specific heat, and the temperature change to calculate the heat flow during a chemical or physical process. The relationship between heat, which we represent with Q, can be found by calculating the mass times the specific heat times the delta T, our change in temperature. Given the mass, specific heat, and delta T, we calculate Q, which is our heat. Let's read through our first question. The specific heat of iron metal is 0.450 joules per gram Kelvin. K stands for a Kelvin unit. Even though our temperatures will be given to us in degrees Celsius, don't let that bother you. A Kelvin unit and a degree Celsius unit will show us the same change. Joules per gram Celsius is also a correct unit for specific heat. So here we are being told the specific heat value, which is C, 0.450 joules per gram. And why don't we go ahead and think in our head degrees Celsius? How many joules of heat, that's asking us to solve for Q in a joule unit, are necessary to raise 1.05 kilogram block of iron? The kilogram unit will need it to be converted to a gram unit. We would do that by saying that there are exactly 1,000 grams in every 1 kilogram. So we'll need to slide our decimal 3 spots to convert kilograms into grams. The delta T can be found by simply taking T2, which is 88.5, minus the 25 T1. It's a plug and chug formula. Given the mass, the specific heat, and the delta T, we'll calculate Q. The mass, again converting, 1.05 times 1,000. Hit that on your calculator, and you've converted a kilogram into a gram, and we would see that's 1050 grams. Specific heat of iron given to us is 0.45 joules per gram degrees Celsius. And T2 minus T1, that's 88.5, minus the 25 shows us a delta T of 63.5 degrees Celsius. M times C times delta T shows us heat energy measured in a joules. Hitting for this, we show on our calculator 1050 times 0.45 times 63.5, and I'm showing a value 30003.75 joules. Q is 30,003.75 joules of energy. Our second problem from our homework: how much heat energy in joules is absorbed when 150 grams of water is warmed from 34.8 to 96.3 degrees Celsius? Again, we're being asked to solve for Q. That's our target variable. Our M stands for mass, given to us as 150 grams. The C, specific heat for water, is a constant we have memorized to be 4.184 joules per gram degree Celsius, and our delta T would be T2, 96.3, minus T1, 34.8. We will plug into our formula MC delta T, where we're targeting Q, the heat energy measured in joules, when 150 grams times our specific heat constant for water, 4.184 joules per degree Celsius gram, and T2 minus T1, so I'll hit for us 96.3 minus 34.8. I find 61.5 degrees Celsius as our delta T. MC delta T, hitting that out, 4.184 times 150. I'm showing a value for Q, 38,597.4 joules of energy. In our third homework problem, a chunk of silver has a heat capacity of 42.8 joules per degree Celsius. If the silver has a mass of 181 grams, calculate the specific heat of silver. We are being asked to convert heat capacity, defined as the amount of heat energy necessary to raise the entire object by 1 degree Celsius. We're being asked to convert that into specific heat, which is for 1 gram of the object. We will do this by taking our heat capacity value, 42.8 joules per degree Celsius. Again, defining heat capacity, this is the energy needed to raise the entire chunk of silver by 1 degree. By introducing the mass on the bottom, we can introduce that gram variable to convert joules per Celsius into joules per gram degree Celsius, our target unit for specific heat. We'll simply take 42.8 divided by 181, and I show on my calculator 0.236 joules per gram degree Celsius, our specific heat for silver. Heat capacity is the entire object. Specific heat is if we had 1 gram of the object. In our next homework problem, it reads, when a certain substance with a mass of 100 grams is heated from 25 degrees to 75 degrees, it absorbs 4,500 joules of heat energy. Calculate the specific heat of the substance and use the following table to give it its identity. Each of our substances listed has a unique value for specific heat. Once we find our specific heat, we will match it to identify. Our formula shows Q is mc delta T. Q this time is given to us as 4,500 joules of energy. The mass of our object is 100 grams. Our target variable is C, the specific heat of this unknown object. And delta T will be the change in temperature, T2 minus T1. 75 and 25 shows us a temperature change of 50 degrees Celsius. The calculator sequence says begin by taking 4,500, dividing that by 100, and again dividing by 50. The joules of energy is 4,500 divided by the mass of 100 divided by the delta T 50 shows a value of 0.9 joules per gram degree Celsius. If we examine our table, finding the value of 0.9 is a match for aluminum. We've properly identified this object to match the aluminum value for specific heat. Our answer of 0.9 identified this object as aluminum. Our last problem that will work today, a student mixed 75 mils of water that contained 0.5 moles of hydrochloric acid at a temperature of 22.5 degrees, with 75 mils of water containing sodium hydroxide at the same temperature in a foam cup calorimeter. The temperature of the resulting solution increased to 26 degrees Celsius. How much heat in kilojoules was released by this reaction? Assuming the density of our solution is 1.0 grams per mil. We understand we're being asked to calculate Q, the heat energy. The mass is given to us in pieces. If we take 75 mils of solution 1 and add 75 mils of solution 2, we get a total volume of 75 plus 75 is 150 mils. They're also telling us that grams and milliliters are equivalent, knowing the density of water is 1. So the combined mass of our solutions is 150 grams. The specific heat of water is a constant, 4.184 joules per gram degree Celsius, and our delta T will be found by taking T2 minus T1. 26 was our second temperature where it warmed to. 22.5 is the original temperature we began at. 26 minus 22.5 shows us a temperature change of 3.5 degrees. We now have all the information necessary to calculate heat from this chemical change. Q is our target variable. The mass is the combined total volume turned into a gram. There's 150 grams of solution. The solution is a water solution, so we'll use the specific heat of water, 4.184, our constant we've memorized. And the change in temperature, 3.5 degrees Celsius. We will hit 150 times 4.184 times 3.5 to find the Q, the heat energy. Q is found as 2196.6 joules. The temperature, the question up here asked for kilojoules, so we'll simply divide by 1,000 to convert a joules into a kilojoule, and I'll report that as 2.196. Why don't we round to say 2.2 kilojoules of energy. A kJ is our abbreviation for kilojoules. This ends our homework. Let's turn it in.